we are done with symmetric encryption. We understand what it is and saw its demonstration and project. Now let's see what is asymmetric encryption or asymmetric keys in KMS. So we have already seen that in asymmetric key, we have two keys, private key and public key, and both are mathematically related to each other. Also, in AWS KMS, for asymmetric keys, private key never leave KMS, only public key is publicly exposed. So let's go to KMS console and create one asymmetric key and use it to sign and verify a JWT token. And commands can be found here. So in the GitHub repo, I have added all commands for symmetric encryption, key grant, and asymmetric encryption. Asymmetric encryption to create a JSON web token. So you can find it in the repo. Now let's create a key. Let's get asymmetric key. And asymmetric key can be used for three purposes: encryption, decryption, sign and verify, and key agreement. And in all these scenario, only public key is available to be shared with others. So in encrypt decrypt, public key will be shared, and clients will use public key to encrypt something and send to S3 or send to AWS. For sign and verify, signature will be created with the help of private key, and verification will be done with the help of public key. And in key agreement also, only public key is available to be shared. I have not explored this option much, but for now let's select sign and verify, because this is what used to create JWTs. For key spec, let's select RSA 2048, and advanced options, let's keep default and create our key. For alias, let's call it JWT key, because we will use for creating JWT. And administrator and user, let's not select anything. Default policy is sufficient for admin user. And finish the creation of key. Now if I go to JWT key, under cryptographic information, I can see it's a symmetric key and purpose is sign and verify. In public key, I can see my public key, and this is the key which we can expose somewhere, maybe some public endpoint we can create, and we can expose it so that the tokens which we create can be verified. Now let's open Cloud Shell and use AWS KMS CLI commands to use this key and create a JWT token. So these are the commands. First we will create header, then payload. Before we create JWT, let's quickly review the structure of a JSON web token. So here I have ID token and it's JWT. So JWT is made up of three parts: header, and then payload, and then signature, and all are separated by dots. These are just base 64 encoded values. If I convert them, then we can read this JSON data as a string. So what we will do is that we will take two JSON objects, header object and payload object. Then we will convert them to base 64, and then we will create hash and sign the hash to generate this signature. Then we will join header, payload, and signature by dot. So let's start. First I will copy this. Here we have header, and this is our JSON object which contains algorithm information and type as JWT. In payload, I have sub, name, and IAT, means at what time created and some random data here. Let's copy it and paste in the Cloud Shell. So for this JSON, this is base 64 value, and for this JSON, this is base 64 equivalent value. And now let's create this variable string to sign. And for this, first thing we need is this header, base 64 version of header, and then payload. But in payload, make sure to remove this equals sign and copy from E to 0 and paste it here. So this is our string to sign. Now let's hash the string using OpenSSL utility, and this is the string which we have to sign using KMS asymmetric key, and this is the command. So it is AWS KMS sign, then which key ID we want. So we will use alias as JWT key, which is here, and what is our message which we want to sign. So this hash string we will sign. Then message type is digest, signature algorithm, and query as signature. We will take output and do base 64 decode. So let's copy it and paste here. Now we have signature or signed value from KMS. Now we can join signature, this header and payload to form proper JWT. So let's do that. We have signature joined by string to sign, and finally we will echo final JWT. So let's paste the command, and this is final JWT from here to here. And if I go to jwt.io, I can paste. Looks like it's not copied properly, so I will copy it again and paste it here. Still looks like there is some error. It's not doing proper copy. Okay, it's pasting only till this k. Let's copy this value again and try to paste. And it pasted till x only. Okay, I need to copy all line one by one. And then this line. And then finally this line. I forgot to make it big while running commands, but you can find them on GitHub, so it's fine. Now we have valid JWT, and for this JWT, this we have header info, payload info, and now I need to put my PEM key, public key, to verify if this JWT is valid or not. And key we can find here in KMS key section. If I go to public section, I can copy my key and then I can paste key as it is here, and it's safe to do so because it's public key and that's the purpose. And after pasting the key, it says signature verified. Now if someone tries to tamper this message or any value, if basically any value is changed, then again it will start showing error for this signature. It will say valid signature. So we can use this JWT in JWT based authentication, and that's what the next project which we are going to make, which is JWT authentication server. So I will scroll down a little bit, and here this is architecture of our server.